Hello everyone, welcome to this series of videos where I'll be talking about the use of analytical models in supply chain design. Last week we looked at a few models where we were able to use the gravity location model, a couple of versions of the gravity location model, to figure out where to place a single facility. What we'll be doing today is we'll be going over a model called the capacitated facility location model. And this capacitated facility location model is going to help us figure out how to figure out how to place multiple locations, right? So we did a single location, now we'll see multiple locations. Now, the capacitated facility location model is pretty versatile and can be used for in different scenarios. The first scenario we'll talk about is where you're doing very high level planning of figuring out which markets to enter, where to generally place your facilities and so on. And later on, either later next week, we'll look at more specific examples. In fact, even in the synchronous session, we'll look at some specific examples of smaller, more targeted usage of the capacitated facility location model. All right, but today let's begin with the facility location model. So this is when we use the capacitated facility location model to design a regional network configuration, right? So we're talking about regions in general, we're not talking about specific locations. So what do you need in situations like this? You need the demand, you need the desired response time, fixed costs for operating the facility, variable all the different sorts of variable costs involved with it, including labor, material, holding costs, transportation costs, and whatnot. Of course, sales price of the product is useful. If there are any taxes and tariffs, that would be useful. And definitely, we would need to know what the capacity of the facility is. And I mean, the name of the model is capacitated facility location. So we're looking at facilities that have capacity, which is all real life facilities, right? They have limited capacity, and it would be good to know what that capacity is, right? Now, taxes and tariffs, we will discuss, we will see how that affect supply chains, but we'll do that next week. This week, we'll do the basic capacitated facility location model, and we'll see how much we can get through this week, right? So this is the example that we'll be using this week. Here is an example of a company that has markets in all continents and has is trying to figure out where to locate its manufacturing facilities, right? So they're making some sort of widgets, and these manufacturing facilities can be located in any of these 5 regions, either in North America, South America, Europe, Asia, or Africa. And they have demand in all of these 5 regions, North America, South America, Europe, Asia, and Africa. And the numbers that you see here are the demands for these regions in millions of units. So North American demand is 12 million units, South American demand is 8 million units, European demand is 14 million units, and so on, right? Now, on top of that, you also see the numbers here. These are the costs of production and transportation. So you're saying that if you build a plant in North America and you have to service all your customers within North America, it's going to cost you $81,000, I'm sorry, cost data in thousands of dollars. So it's going to be $81,000, right, per every million units, right? So we are looking at millions of units, so it's all going to be in millions of units. So that's it. So $81,000 for million units. If you build a plant in North America and you're servicing clients in South America, markets in South America, it's going to cost you $92,000 for every million units, and so on. So these are the variable costs that are involved per million units. And these are the fixed costs. So for me to build and run a plant in North America, it's going to cost about $6 million, right? So it's 6,000, but it's 1,000. So it is $6 million, right? And the capacity is right here. The capacity is 10 million units. So that is a low capacity plant. You can also build a high capacity plant in North America. The fixed cost for running that will be 9 million units, and the capacity will be 20 million. Sorry, now fixed cost will be $9 million and the capacity will be 20 million units. So you could either build a low capacity plant or a high capacity plant, or maybe you want to build both, depending upon what your demand is. Very unlikely that you'll build both, but that's the idea. Now, one thing I want you to notice is that when you double the capacity, the fixed cost doesn't double. In most of these cases, you'll notice that the fixed cost is just 1.5 times, right? And that is because you get economies of scale, obviously, larger plants and all of that. And so that's the basic idea here. Now, I'm going to keep all the units in millions of units and all the cost values in thousands of dollars. So in the end, the numbers might look small, but actually they are pretty large numbers. All right. So that's the data here. Right. So I'll quickly go over how you usually model something like this. You all have very likely taken the spreadsheet modeling class, and if you haven't, that's okay. I'm not assuming that you've taken it, but you all, for those who've taken the spreadsheet modeling class, you've seen linear programming, right? And so this is obviously based off of linear programming. And the way we model this is, so all the locations where you can potentially place your manufacturing facility, your production facilities, they're all called supply regions. And all the places where you have demand are called demand regions or market regions. So you have supply regions and market regions, or supply regions and demand regions, right? So that's what you have here. And you say that we have N is the number for the potential plant locations. M is the number of demand points, right? So N and M could be any numbers depending on the special case. Now, in this particular problem, N is 5 and M is also 5, right? So there are 5 potential locations for plants and 5 potential locations for 5 potential demand, not potential, 5 demand locations, right? So M is 5. Right? Now DJ is the demand for market J. So you say that D1 is the demand for market 1 for us. So if you number the markets 1, 2, 3, 4, and 5, D1 will be demand 1, which is 12 million units, right? So that's the basic idea. So this is how you do it. So you use D for demand, K for potential capacity of a plant, right? So if you're looking at low capacity plants, K will be 10. If you're looking at high capacity plants, K will be 20. All right. Now, F is the annualized fixed cost. So we know the fixed cost values for low capacity plants and high capacity plants. And Cij is the cost of producing and shipping 1 unit from plant I to market J. Right. So usually the thing to keep in mind is that Cij is the variable cost. Now, in this case, the only variable costs that we are looking at are production and shipping. But in reality, this might include production, inventory, transportation, tariffs, all of the costs that are incurred per unit, that are all variable per unit, are all going to be here, right? All the costs, right? And we'll assume, one of the assumptions we make in the model is that we know all of these costs, and that is not a bad assumption to make, because you are making a plan. For you to make a plan, you have to assume something about the costs. Otherwise, you won't be able to make a plan. All right. We have 2 sets of decision variables. So once you solve this problem, there are 2 sets of variables for whose values will tell us what to do. So Y will represent, there'll be 5 of the Y's. So Y sub I for every potential plants that you have. In this case, there are 5. In fact, in this case, there are 10 different potential plants, right? Because you can either open a low capacity plant or a high capacity plant. So there are 10 different types of plants that you can open. And if the value of Y is 1, then you're opening the plant. Otherwise, if the value of Y is 0, you're closing a plant. This sort of variable is called a binary variable. So binary variable can take only 2 values. In this case, it's 0 and 1. Usually it is zeros and ones. 0 represents the fact that you're not opening a particular plant in a particular location, or a particular type of plant in a particular location. And Y being 1 means that you are in fact opening that plant. Now, Xij is the quantity shipped from a particular plant to a particular market. Now, things to keep in mind is that if you're not opening a plant, then you're not going to be able to ship anything from there. But the idea is that we'll make all of these decisions together. That's the that's the thing that you get out of the capacitated facility location model, right? It is a really good model for you to be able to make multiple decisions of plant location and also figuring out how much capacity is being used and what kind of demand locations you're going to go to. All of that can be figured out in a single model. And that's the usefulness of this particular model, right? And we'll go through that. So we'll set it up in Solver and we'll solve it. A lot of the information is here, the demand constraints and all of that. So in general, there'll be three big constraints. There'll be one constraint letting Excel know that the Y variables are all binary. There'll be one constraint for demand and one constraint for supply. That's how usually these network models work. You'll have a supply constraint, a demand constraint, and a binary constraint, right? Okay, you know what? Instead of speaking of these in generalities, let's actually solve this problem. Right? So I am going to move over to my Excel file. All right, here we are with the Excel file. So this is the exact same data that we had in the PowerPoint file right here. This data right here, I have just copied it over. Right now, the book has a certain way of solving it, but I'm going to make a slight change because that is useful when you're solving different kinds of problems, and you'll see what I mean by that. So this is the data here. What I'm going to do is I call this original data. I'm going to make a copy, and I'm going to what I'm going to do is I am going to make a slight change in the data. Instead of calling original data, I'm going to call it revised data, right? Now, what is the change that I'm going to make? So instead of having low capacity plant and high capacity plants here, the way I like to set up is that every potential plant location gets its own row. And every demand location gets its own column. So the demand locations are already in columns, but I want to set up the low capacity plant locations and the high capacity plant locations differently. All right, so let me do that. So what I'm going to do is I'm going to replicate the region. So here I'm going to change the name here. I'm going to call this North America high capacity, South America high capacity, right? Now I'll need 5 more rows. I'm done. Right? I'm gonna insert me some 5 rows. Right? Good. I'm going to make this, copy this over. Right? So I'm going to call this. So I'm going to call. Actually, you know what? Let me do low capacity on top. Low capacity, low capacity, low, and low there. Okay, so these are going to be my going to represent my potential supply regions if I open a low capacity plant. These are my potential supply regions if I open a high capacity plant. Now, whether I open a low or high capacity plant, the variable cost is the same. So I'm just going to replicate my variable cost. I'm just going to replicate that right there. It's the same variable cost. All I did was copy this and paste it here. You'll notice it's the exact same thing. Now, by doing this, what I'm doing is that I'm going to move my fixed cost and the capacity. I'm going to move that over there. All right. I don't want to do that. Just copy. All right. This I will delete. Okay. Now, why did I do this? So by doing this, every potential plant location that I have is a separate row, right? And this also gives me a few things where it's easier to write my formulas and such. So I like setting it up this way, right? Now, once I have this, the next step is for me to set up a place where I can have my final solution, right? So once I have this, I'm gonna, you know what? Let me make this bigger. It's okay. So once I once I solve the problem and get the final solution, I will need values of values of x and xij's and the values of y, right? And the way I'm going to set that up is this is my supply and demand regions. I'm just going to take that right there. I'm not including demand. You'll notice. Should I include demand? No, I don't want to include demand. There you go. Now, all of these. Okay. Now, Now, all of the values here, these are all my variable cost values. And these variable cost values, so I'm just going to fill this up. I like to fill up, you know what, let's include, I don't like the massive thing of red. So this is where the final, so this is where all the Xij values are going to show up. So this is going to tell you how many units are produced in the low capacity North American plant and then sold in North America. This is going to this is going to represent the number of units that are manufactured in the high capacity South American plant and sold in Asia. Now remember, you don't have to locate a plant in every single place. The whole idea of solving this problem is to figure out where should we locate these plants? Should they be high capacity? Should they be low capacity? And once you locate these plants, how do you take the materials that you manufacture in those plants and then satisfy all your demand, right? Now, a few things before we proceed. If you add up all the capacities of all potential plants that you could place, right? If you place low capacity plants and you place high capacity plants, you can essentially produce 150 million units, right? That's how many units you can produce. But demand, if you add up demand is only 57 million units, right? So if demand is only 57 million units, it does not make sense for you to open so many plants so that your capacity is really, really high. You're likely going to open plants because everything here, capacity here is multiples of 10. You're likely going to open enough plants to end up with 60 million in capacity. Very likely, right? Or maybe 70 if there are some, special cost savings or something like that. But otherwise, it's very likely that you'll end up open enough plants to have 60 units of capacity. Right? Now, you don't have to do any of these analysis. All of the values will come out straight from solving this problem. But I'm just trying to understand what this solution is going to be like. So this could mean that you could open like 4 low capacity plant and 1 high capacity plant, or you could just open 3 high capacity plants, right? Now, what happens exactly? Well, we'll find out once you solve the problem. You don't have to guess. You don't have to do anything. Just have to set it up correctly and solve it, right? So let's do that. All right. Going to move my right there. Okay, I had a little issue with my computer, so I had to stop and restart the recording. I'm already coming up to 20 minutes. So I'm going to do a couple of things here, and then I'll post another video for the remaining solution for this problem, right? So this is where we are going to find all the values of Xij's, and this is where you're going to find all the values of the Yij. So I'm going to call this open or close, right? Is it open or is it closed? Now this is where the final solution values of 1s and 0s will show up, telling us which of these plants are open or closed, right? So let me mark that with maybe a blue. All right. Okay. Blue for open, close, and red for Xij's, right? So once you have that, the only other important thing to figure out for our decision, so there are 2 important things to do before this. One is figure out a place for cost, the total cost, because when you're doing optimization, you're either trying to minimize cost or maximize profit. This is an example of minimizing cost. That's because we don't have any data about sales price or anything like that. If you have data about sales price and tariffs and all of that, you would likely solve this problem as maximizing profits or maximizing revenues rather than minimizing cost. But here we are doing cost, so let's just do total cost, right? And this is where I'm going to write the formula for total cost. So I'm going to make it green because, green for money, right? So right there. So that's where my total cost is going to be, right? Now, once you do that, you have to set up constraints. You have to set up supply constraints, demand constraints, and then you also have to set up binary constraints and all of that. So we'll go through all of that process. But what I will do is we'll set up the cost here, and then I'll, you know what? It's okay. Even if the video is longer, let me just go through the whole thing in a single video. I don't want to break it up. Let's just get it done. All right. So I'm going to go a little bit quicker. Don't mind. Now, cost. So if you look at the formula for cost, there are 2 portions to this formula of cost. You have the variable cost and fixed cost, right? Now, fixed cost is only incurred if you open a plant. So that is why you'll notice that when you write the formula for fixed cost, it is Fi times Yi. So remember that Yi is a binary variable that it takes a value of 1 or 0. So if it takes the value 1, then in the fixed cost will be Fi times 1, which means that you are incurring the fixed cost. But if you're not opening a plant and Y is 0, then the cost will just be F times 0, which is just 0. Right? So that's a nice thing about setting up the 0, 1 variable. So it lets you either incur a fixed cost or not incur a fixed cost, depending upon whether you placed the facility there or you did not place the facility there. Right? So that's what makes it so useful. Now, the other part is obviously the Cij times Xij, the cost of transportation and production times the number of units that you're transporting and producing. Right? So that's the total cost. And the simple way to write that is, so how would I write the total cost? So total cost has two components. So I'm going to temporarily write a couple of formulas here, and then I'll show you how to write a simple in a formula here. So if you're just doing variable cost, what you're doing is you're multiplying this number here with the corresponding cost, this number here with the corresponding cost, this number here with the corresponding cost, and you're just adding them up, right? And to do this in Excel, like we saw last time, when you're multiplying corresponding numbers together and you're adding them up, you can use the sum product formula. So you're summing products. So I'm going to use the sum product formula. So the variable cost, you just say sum product, right? Oops. Sum product of all the variable cost values. So just the variable cost values, don't include demand, don't include the fixed cost. So all the variable cost values, comma, all your Xij values, right? So this here will be your, just your variable cost. So, right, oops, I think so that will be your variable cost. So this will be the all the variable cost, individual variable cost values, and this will be the number of units that you're transporting. So variable cost times the number of units is the total variable cost, right? So that's the total variable cost. Right now it will be zeros because there are no numbers here. And obviously, if you're calculating fixed cost will be all the fixed cost numbers, right? Times the corresponding open close variables. Now this is not a formula, right? So I was just trying to show you something. So even here, so you're going to multiply 6,000 with this number. If this number is 1, you will incur the 6, so it's actually 6 million, but you know that. If this number is 1, which means that you are opening a low cost plant in North America, then you will incur the $6 million cost. So it'll be 6 million times 1. Otherwise, it'll just be 6 million times 0, in which case you will not be incurring the cost. So again, you're multiplying corresponding numbers together and you're adding them up. So you can write another sum product formula for the fixed cost. So you can write a sum product formula for fixed cost, you can write a sum product formula for variable cost, and you can add them together, or you can write a single sum product formula. This way you can just say sum product. If I can spell correctly, sum product of all the cost values, fixed cost, these are the variable cost values and the fixed cost values, right? And the fixed cost values, comma, don't forget the comma when you do sum product, the Xij values and the Y values. Because we wrote them right next, so because I set it up the right way, this is the reason why I set it up the way I set it up. Because I set it up the way I set it up, all the variable cost values are here, all the fixed cost values are here, all the Xijs are here, and all the Yijs are here, right next to each other. So that way I can write a simple formula for the total cost, right? So there you go. That's my total cost, and that's where the total cost is going to be, right? So that's my cost values. Now, after setting up the cost, I have to set up constraints, and once you do the constraints, we'll put it into solver and we'll solve it, all right? Okay, so let's begin with, so that's my total cost. So once you do that, so remember that there are 3 constraints that we need to do. Now the third constraint, the binary constraint, we will set it up in solver itself, but we'll set up supply and demand constraints first. So let's do the supply constraint first. So supply constraint, now note that total capacity that you have, potential capacity that you have on hand is way more than potential demand, right? And this will be true for most of these cases. In such cases, what you do is you set up supply constraints as less than or equal to constraints, because you're not using up all your capacity. That's the maximum capacity you have, and you can use less than that, right? So how do you set them up? So whenever you write a formula like this, you'll notice that whenever you write a formula, you'll notice that there's a left-hand side to the formula and there's a right-hand side to the formula. And the left-hand side is usually, Greater than right hand side, less than right hand side, however you set up. There's a left hand side and there's a right hand side. One side of the formula is the total capacity that you are, or the total that you're supplying out of a plant, right? And the other side of the formula tells you how much capacity you have. So if you have 10 million unit capacity, you cannot supply more than 10 million units from that plant. If you have a 20 million capacity, you cannot supply more than 20 million from that plant. Moreover, if the plant is not open, then you can supply nothing out of that plant, right? And that is what we have to set up. And this is how you do that, right? So I'm going to say supply constraint. So because I'm doing supply constraints, I'm going to write one constraint for each of these supply regions. I'm just going to copy that out just to make my life easy a little bit. I'm just going to put it right there. Right? I'm going to call this supply constraints. Spell it correctly, hopefully. All right. It's not North America. South America, I'm going to say amount supplied out of this particular location. But I'm going to move my face a little bit. Amount supplied and capacity. Right? These are going to be all my constraints. Okay. Now, right here, none of these numbers matter, so I'm going to get rid of that. So the amount supplied. So what is the total amount of units that are supplied out of the low capacity plant in North America? And the way you do that is simple. So the total number of units that are supplied out of North America is going from North America low capacity plant to North American region, to South American region, to the European region, to the Asian region, and to the African region, right? So these are all the units that are transported out of the low capacity North America plant to all the different demand regions. So you add them all up, right? That's the total number of units that are supplied out of the low capacity North America plant, right? And that's the left hand side of the constraint. And this has to be less than or equal to the capacity of that plant. So what is the capacity of the low capacity North American plant? Well, you'd say that the capacity is 10, but the capacity is 10 only if the plant is open. If the plant is not open, it doesn't have any capacity because the plant is not there, right? So when you write capacity, you write it as, well, it has to be 10 million, but only if the plant is open. And how do I know if a plant is open or not? Well, I can multiply that with this variable. So this is the variable that tells me whether this plant is open or not. So if this variable is 1, the plant is open and the capacity is 10. If this variable is 0, plant is not open and capacity is 10 times 0, which is just 0. So if it is 0, then you cannot supply anything out of it. So we'll say that this number here has to be less than this number here, right? So that's my constraint. And because I set it up the right way, I can just, copy the formula all the way down. Just choose the whole thing and copy the formula. So you'll notice that this says everything coming, right there, right? So everything coming out of the European high capacity plant has to be less than or equal to the capacity of the European high capacity plant, which is 20 times whether or not the plant is open, right? So those are my supply constraints. Now supply constraints will be amount supplied is less than or equal to capacity. But demand constraints, which we are going to write next, will be equal to constraint, saying that you have to exactly meet demand. It cannot be less and it need not be more. All right. So let's write demand constraint. So because demand is in columns like this, that's how I'm going to set it up. Right. So I'm just going to do the same trick that I did there. Just going to copy that over. I'm going to put that right there. All right. So I'm going to say the amount that is supplied to each of these demand regions, and then this is the actual demand. Get rid of these. So what is the total number of units that are supplied to North America? To the demand region North America, not the high capacity or low capacity plants. You're talking about the demand region of North America, right? So the total amount of units that are supplied to the demand region of North America is the sum of everything coming from all these different plants into North America. And that is right here. So these are all the units that are coming from all of these different plants into North America. So North America, low capacity plants, South America, low capacity plants, Europe, Asia, Africa, low capacity plants, and all high capacity plants. So all the numbers here represent all the supply that's coming into this demand region, right? And the demand constraint says this, or the sum of all of these numbers has to be exactly equal to the demand of this region. And the demand is 12 million units, right? Right there. So the total of all the supply coming in has to be exactly equal to 12. And again, because I wrote my formula correctly, I can just copy this whole thing over. And my formulas will work. 12, 8, 14, 16, and 7. 12, 8, 14, 16, and 7, right? And let's check Asia. Asia is the sum of all the units coming into Asia, right? And there you go. So now I've set up my demand constraints, my supply constraints. I've set up my objective, which is to minimize cost. The only thing that I've not set up directly is the binary constraints, but that we'll put directly into solver. So I'm going to go to data. I'm going to open up solver. Yeah. Open up solver right there. Right. I'm going to put my face on this potential. Right. Okay. I don't know if you can see my face here, but there's a floating screen. All right. So we are minimizing total cost. So I'm just going to choose minimize, right? And the objective is to minimize cost. And we wrote the objective somewhere around here, right there. So that's our total cost. And that's our objective. Our objective is to minimize this total cost, 829. That's where our objective is, right? Now the changing variable cells, so all the cells that are xij's and yij's, don't forget to include the yij's. So everything right here, all of these are my changing variable cells. These are all my decision variables, right? Everything from B17 all the way up to G26, right? Okay. Now let's add some constraints. Now before you do that, you see that when we did the gravity location model, we left this as non-linear because they had square roots and squares and all of that. But this is all linear. So I'm just going to change this to simplex LP. LP stands for linear program, right? Change that to simplex LP. And now we'll add the constraints. First, we'll add the supply constraint. Now you can add each supply constraint one by one, or you can add them all together. And this is how I'm going to do. If you go here, I'm going to say that, so you have the left-hand side of a constraint and you have right-hand side for a constraint. So I'm going to say that all the amounts that are supplied, so I'm going to choose them all. So everything going from L3 to L12, L3 all the way down to L12 has to be less than or equal to, so it's already less than or equal to, so I don't have to choose anything, is less than or equal to the corresponding capacity value. Now the capacity value can either be 10 or 20 or 0 depending upon how things work out. Wow, this is a really long video. I'm really sorry. I should have split it up into a couple of videos, but I didn't plan this properly. That's fine. So all the left-hand sides are less than right-hand sides. So I'm going to click on add. That's my first set of constraints. Now, if you had clicked OK, all you would have seen is gone back to this screen. You can just click add again, so it doesn't matter. And now the demand constraint, we say that all the demand values, so all the amounts that are supplied to the different demand regions, North America, South America, Europe, Asia, and Africa. So the top row has to be equal to, so this time it has to be exactly equal to, not less than. If you do less than, you'll just get zeros, right? Exactly equal to the constraint, which is demand, right? So yeah, all of these numbers have to be exactly equal to the numbers below that. And click OK. Now there's one more constraint to add, which is the binary constraint. So this is where I'm going to add a constraint. Then I'm going to say that all of these numbers here are, you see, int, bin, and div. So int means that integers, they have to be whole numbers. binary is binary 0, 1, which is what we are going to choose. There's also a third type called diff. Diff is where instead of using 0, 1, you might want to use 1 minus 1. So sometimes it makes sense to define decision variables as 1 minus 1 instead of 0, 1, but we are doing 0, 1, so I'm going to choose bin. You cannot just type binary, that won't work. You have to go here and choose bin in the middle. I'm going to click OK, right? And then finally, the only thing I have to do is click on solve, and there you go. Now, few things to notice. You notice this weird number here, and you notice this weird number here. That's okay. So you notice that it says 1.1102 E minus 16. So E minus 16 represents the fact that that is 10 raised to minus 16. So E is just Excel's way of saying 10 raised to the power of 10 raised to minus 16 means that you have 0.0000. You have 16 zeros followed by 1. This is essentially 0. Just that sometimes it's slightly above 0, but it doesn't matter. So when you get numbers like this with E minus something, then you know that it's basically 0. And the way to manage that, if you don't want to look at it, there are a couple of ways of doing that. You can just, say that all of these numbers here have to be just regular numbers with no decimal places, right? So you can get rid of that way. Or the other thing that you can do is you choose these numbers and change them to number, right? And then get rid of the decimal places. Right? So that doesn't mean anything. It doesn't mean anything. You got the right solution in what, right? Now let's see what the solution tells us. Now, like I said, we were likely going to open enough plants so that our capacity is 60 million. And it turns out, given that we have economies of scale with high capacity plants, you are opening exactly 3 high capacity plants, and you're opening them in South America, Asia, and Africa. So those are the 3 locations where you're opening your high capacity plants. And the reason for that is you'll notice that those are the cheapest costs. But that's not something that you can automatically assume, because sometimes the transportation costs might be cheaper, even if the variable costs are not, right? So that's the thing to keep in mind. So you're opening high capacity plant in South America, one in Asia, one in Africa. So the South American plant will supply everything everything, all the demand of South America, which was 8 million units, and 9 million units of demand in North America, right? So it has a capacity of 20 million, but you're only using 17 of that. Why? Because the high capacity plant in Asia, 3 million units is coming to North America to satisfy the remaining demand. 16 million units is staying in Asia to satisfy Asian demand, and 1 million units is getting shipped to Africa to satisfy African demand, right? And finally, the plant in Africa, 14 million units of everything manufactured in Africa is getting shipped to Europe to satisfy all of European demand. And 6 million units are staying back in Africa, with 1 million unit coming from Asia. That this total will satisfy demand in Africa. And the other thing here is you can notice that everything here is 0 for your capacity constraints. But South American plant, you have a capacity of 20, or you're using a capacity of 17. Both Asian and African plants, you're using maximum capacity. Capacity is 20 and you're using up 20. Now, for all the other numbers, you'll notice that all capacities are 0 because you're not opening those plants. Now look at demand constraints. We wrote them as equal to constraints. So these numbers are all right, exactly equal to each other, which means that all demand is satisfied, right? And that is how you solve this problem. So by solving this problem, we figured out that we are going to locate 3 plants, one in South America, one in Asia, one in Africa. We know exactly where we are sending those, shipping those materials that we manufacture in these 3 plants, and how our supply chain is set up. And this is a basic supply chain regional facility design, right? So this video is way too long, 40 minutes. So I'm going to stop here. I might do another couple of examples over a few weeks, but I will post those videos later, right? But this is the capacitated facility location. And yeah, so I hope if you have any questions, feel free to email me, and I'll see you all in the next video. All right, take care.